In our second example, we want to draw an enclosing circle for a set of randomly generated points, and this enclosing circle shall be as small as minimal. So a minimal enclosing circle or bounding circle for a set of points. You see here in this in the Rhino window our randomly generated set of points. So we have them here. And the circle that we generate, I just go to the definition below, but it's doing the same. It's controlled by these two sliders that draws the center point of a circle. And here I move around the x and y coordinate of the circle, and the radius of the circle is as large as the largest distance to one of the points that's necessary to enclose all the points. So that's what's been done here in the middle part of the definition. There we compute the distances to all points, and here at the top group, the group at the top, we compute again all possible circles in a grid that we draw in the area of these points. So we create here, how many do we create? 100 by 100 points. I should see this here, right, which means 10,000 points in a grid. We can preview this grid. If we zoom in, so here you see we have many points, and for each of these points we generate a bounding circle. We do this to create again our fitness landscape, because we look for the smallest bounding circle. Therefore we compute the area of each bounding circle, and here in this part of the component of the definition we sort the areas and just take out the solution with the smallest area. So if we preview this one, that's the smallest bounding circle that we found, with an area of 133 point a little bit. What you can see here is that it is not the most optimal bounding circle, because the most optimal one would have exactly three points on its shape on the circle itself. So this one should be on the boundary, but since we use this grid of points, obviously the best solution is somewhere in between the generated grid points. But what we can do is to show the landscape again. Here we change again to the perspective view. What we have here is our fitness landscape. I've drawn it more or less above the rectangle that is used to generate the points randomly into it, so it looks very similar to the real area itself. What we can see is that the center point of the circle is somewhere in the middle. So here we have our most optimal solutions, and that's again our fitness landscape. Of course, at the edges the solution is the worst, because there we can not find the center point of the minimal bounding circle of this point of a set of points. Okay, so the idea is the same as in the example before. I've just added this because, as you see below, we have the same problem, but with the Galapagos evolutionary solver, which we will use in our next example session, where we test if we can find a better solution by running an optimization.